Hi students, I am Professor Veena Joshi. I teach in the Department of Geography, Savitribai Phule, Pune University. I teach the course GG 111 Fundamentals of Geomorphology, and today we are going to see a very interesting topic of this paper, and I believe you will enjoy it. If you remember, in the last lecture we did weathering. Weathering is preceding all the form of erosion. The rock, if it is not softened and broken by weathering, no agent of erosion can work on that. And therefore, we call weathering to be one of the most ubiquitous features and processes which are there on the earth. So, we saw that now. The next will be doing mass movement. Okay. We will be doing mass movement or mass wasting in this talk or in this lecture. What we will be doing is, first we will be defining what mass movement is. Then we will see what are the different types of mass movement, which are the areas where more type of mass movement will be found, and ultimately what are the factors that will be influencing this mass movement process. So now let us begin with the topic mass movement. It is also called as mass wasting. Sometimes we even call it as slow failure. When we travel along the ghats or alongside the road by either railway or by bus or car, it's a very common scenario that we see a lump of rock or soil is just falling in front of it. What we see is nothing but landslide, which is one type of mass movement. It comes in the newspaper every year once the monsoon starts from the Himalayan area or from the Western Ghat area. We keep on getting this news that the pilgrims that go to Badrinath or Kedarnath or Amarnath, they are stuck because of the rock fall or because of the landslide. So, mass movement or mass wasting refers to the downslope movement of rock or regolith or soil. It can be rock, it can be broken rock, or it could be soil under the influence of gravity. So, this is very important. It is the downslope movement of any material, could be of any size, but only under the influence of gravity, not by any other force, not by wind, not by rain or not by anything. No push factor is there, it is only pulled by gravity. And they occur along on the hill slopes because, needless to say, gravity will be working only from the high ground to the low ground. So, when we talk about mass movement, we are not talking about a flat area. We are talking about, it's always hill or a mountain and material which is moving down from there. It can even occur on the valley side slope of a river also. So, wherever slope is involved, where mass movement occurs. Hill slopes have three components: the top convex form, the central or middle part which we call it as rectilinear or straight slope, and the down part, it is the lower concave part. And hard rock and soft rock play a very important role in slope formation. In the chapter of weathering, we have seen that physical weathering gives rise to landscape which is very sharp, because rocks are broken by different types of physical weathering like frost shattering or sheeting, exfoliation, whatever. So, if we happen to fly over a desert, we will see the landscape very sharp, rock are sharp edged. This does not occur in the areas where the rainfall is very high, for example, tropical area or equatorial area. There, because of deep chemical weathering, the edges become smoothened and the rocks becomes, slope becomes kind of smooth. And therefore, we do not see very sharp break in the slope. A top convex slope, the straight rectilinear slope and the concave slope at the bottom, they all merge smoothly in case of humid tropical area, whereas in the semi-arid area, it will have a very well defined geometric shape, flat top, a cliff, a slope, middle slope or talus slope and a flat pediment slope. Such kind of pictures we will get plenty. It always involves a top flat area, a steep cliff area, a middle transportation slope area and finally the area where the deposition take place, that is always near a base level. And we need to remember that there are three functional zones in any geomorphic setup and hill slope is no exception. The area which are close to the hill slope, the main function is degradation or removal or erosion. At the central or middle portion, mostly the material which is getting transferred from the hill slope will be transported down slope, and area which are very close to the base level near the river, all the material that have been removed from the hill slope and transported in the middle slope will get deposited. So, these are the three functional zone, and we also see the sorting of the sediment, coarser near the hill slope, a little finer at the central and very fine near the river. Classification of mass movement. Mass movement based on the way the material are falling, it can be divided into four parts or four division. Falling, that is fall, flowing and sliding and subsidence, these are the four. Fall and subsides involve the vertical movement up and down. So, when we say subsidence, land is sinking. When we say rock fall, the rock is falling. So, it is falling. And when we say slide, it is like Ghasargundi. There is a plane and material is sliding on a plane. And when we say flow, it involves some fluid. Material is mixed with fluid and it starts flowing down slope. So, these are the four main types. Any slope, whether it is steep or gentle, at any point of time, two forces are working. One is the driving force and one is the resistance. The driving force is driven by gravity, and also there are many other factors. It is always trying to pull the material down. At the same time, another force is happening, that is the resisting force. All the rocks are resisting. If these two forces are equal, the slope is stable. So, driving forces are the force which move earth material downslope, and the downslope component are weight, vegetation, fill material, building. I will give you an example. On the same slope, if there is a big stone and if you place it, it will roll faster, longer, whereas if you keep a small stone, it will not move very fast. So, the size of the material, then vegetation also plays a very important role. So, the driving force is always trying to pull the material down. At the same time, the rock is resisting, but this resistance also is dependent on how weak or how strong is the resistance. If it is a deeply weathered rock, because weathering we have already done before, it weakens the rock, then it is very easy for the gravity to pull it down. And whenever we talk about mass movement, there is always a slip plane. That means it is always along a plane that the material is sliding down, and that also plays a very important role, because in what way the geological setting is there plays a very important role. So, the safety factor, it is the ratio of the resisting force to the driving force, which we call it as SF is equal to RF divided by DF. DF is the driving force and RF is the resisting force. When the SF is more than 1, the slope is stable, and when the SF is less than 1, the slope is unstable. So, in case the driving force is more and the resisting force is less, the formula will be here now because the driving force is more, it will be more than 1. If dF is more than Rf, then the mass movement will occur. In the opposite way, if driving force is less and resisting force is more, in other words, if Rf is more and dF is less, then the slopes are stable and no mass movement will occur. The classification of mass movement based on the speed with which the mass movement is occurring, how rapidly or how slowly the material are falling down slope. Based on that, we have got rapid and slow, two types. Amongst the rapid, rock fall, landslide and debris flow, and in the slow one we have creep and solifluction. And water also plays a very important role in case of mass movement. That is the reason why we do not get any news of a rock fall or landslide during winter. But once monsoon starts, that is when the news starts coming. Everywhere the rock fall and landslides are happening. Water plays a very, very important role. Let us see how the rapid mass movement works. Rock fall, very common, especially in the rocky areas, deeply weathered areas, very common in Western Ghats. And the rock falling from the top will come and deposit at the foot slope, and we call it as talus or scree. It also forms another slope afterwards. Very common picture. On all the highways where mountains and hills are there, we see the rock blocking. These are all rock falls. And when the material is removed and deposited down, we can see the fresh scar, and at the foot hill we see scree or talus. So, scree or talus is invariable, inseparable part of mass movement. The scree will become in due course of time more weathered, it will become smaller and smaller. Sometimes the scree can be very steep, it can be gentle. The second type is the landslide. Here it is sliding, not falling. Landslide is movement of a coherent mass whose center has moved downward and outward. So, this word coherent mass is very important. The whole block is just sliding, and there is a plane along which the sliding takes place. So, here the slope is now sitting very happily, but a day comes that SF becomes 1, means the resistance force is less than the driving force. That is when the whole thing will start coming down in the form of landslide. It can come down in step, or it can, the speed can differ depending on whatever is the situation that has caused it. The upper portion, which we can see freshly removed rock, that is called as the scar, and the portion which is come at the end protruding, that is called as toe. In the forested areas, it can be very easily identified because there is no, so this is scar, and if the settlement is there, it really is very, very dangerous. And we keep getting news about in Mali a few years ago. This is very common. Landslide has two types, one is rotational, the other one is transitional. the downward and outward movement on a curved surface. So, when we say rotational, the sliding material is sliding and rotating. So, if the slip plane is a curved surface, it is very straightforward. The whole block will come sliding and it will rotate and the face will move upward. So, the rotation of the head and up movement of so the toe will move up and the back will be tilted. So, rotational slide is, if it is a curved surface along which the sliding is taking place, we call it as the rotational slide. And another one is the translational slide. It is occurring on a surface which is smooth. So, it just slips down. It does not rotate. And mass movement can be of enormously huge magnitude or it can be small, but they are occurring everywhere. Small hills or big mountain, wherever slope is there, it is happening all the time. So, the difference between translational and rotational slide is dependent on the surface, whether it is curved surface or whether it is a straight and smooth surface. Rock moves because there is nothing holding it back, generally requires a pre-existing low friction surface. So, if we ask why is a landslide happening, that is because the rock and soil has become very loose that it cannot hold back. So, if we look at it, a lot of it is dependent on a layer of either an impervious rock or a clay. If we look at this picture, there is a clay bed and we all know that clay, the moment water goes into it, it will seal and form an impervious layer. Rain is falling, so the upper portion is saturated and it becomes very weak, and suddenly a day comes that the whole thing has come and debouched into the river. In Himalaya, these kind of lakes are very common. Nainital, as we know it, so those lakes have been formed by damming of the landslides. So, landslide always involves an impervious layer in the form of a hard rock or a clay bed or anything. Debris flow. Debris means debris. Material of all the sizes mixed together is called as debris. And the moment we say flow, we know some water is there, because without water things will not flow. Debris will mix with the water and forms a viscous fluid and gravity pulls it down. Debris is mainly regolith and anything else such as logs and rock fragment and soil, it is of any size, and it is a very fast moving mass of unconsolidated. So, this word unconsolidated is very important in geomorphology. We are talking about loose material, saturated debris that looks like flowing concrete. So, where the construction is there, we all are familiar with the slab process. So, all cement and stone of all the size is mixed with water and it forms into a viscous kind of a fluid. The consistency looks like this. It can carry debris ranging in size from clay particles to as large as this building. When we say debris flow, it just does not contain rocks or soil. It also even contains logs or even car, whatever is there on the way, it just picks up, and it can be very dangerous, very destructive, and they can travel for kilometers. And a debris flow will have all the material ranging from very fine to very, very coarse, and normally what we find is the coarser ones are occupying the front lobe portion. The finer ones are at the back or behind. They are very common in mountainous areas, and naturally all the mass movement they are in the mountainous areas, but these debris flows become really very manance. It can be a big manance, and we cannot miss it. The signature is so straightforward. We will have mud as well as the stones all together, and for kilometers and miles they run before they actually stop. Here I would like to make one thing very clear for all of you. Water is mixed with the debris. So, but it is not the water which is pushing the material. It is the gravity which is pulling it down, because the proportion of water is not that much that it is able to push it. And that what makes this different than the others. And that water itself does a lot of work. So, within the debris flows we can have mud flow, that is percentage is more mud. So, mud and water. Earth flows, it is more of dry material. Lahar, that is in the volcanic areas, hot and pyroclastic flow, and debris balance. So, now we see earth and mud flow. Basically a very viscous debris flow, means very thick, and they are very slow moving. So, earth and mud flows, sometimes we find them in the deserts also, but in the deserts they take the form of, like when the rain falls, desert has got loose sand. That sand is, and rain comes torrential for a few hours and it will stop. It will create an overland flow, and it will mix with all the sand, and mass movement will start flowing in the form of mud flow, which will look like an ocean flowing. So, they are also very common in the desert areas. The next one is lahar. It is an Indonesian word for volcanic debris flow. So, when a volcano occurs, first dust comes, then very fine, and then lava comes afterwards. So, this dust get blown up and rain is mixed with it, and it is mixed with rain and flow in the form of pyroclastic material. We call it as lahar. So, after a volcano, this is very common, that very fine sand, dust which were deposited in and around, mixed with water and comes in the form of pyroclastic material flow in the rivers and blocking, and it runs for miles and kilometers. So, volcanic eruption plus very heavy rain or snow melt gives rise to lahar. Pompeii, this is Mount Vesuvius, which erupted in 79 AD, and the dust fossilized and completely buried the city of Pompeii, and lahar, lots of lahar. We have got examples here, and then debris avalanche, like how snow avalanche is just, it is not rockfall, it is debris avalanche. It just breaks and starts flowing down slope, and when it is mixed with water, it does enormous amount of damage. These are the fast movement. Now, let us see slow mass movement. There are some mass movement, their movement is so slow, and one is creep or soil creep. It is so very slow that their movement is not visible to our eyes. When we travel and when we see the roadside, sometimes we will see the trees are tilting, the fence is tilting. So, what is happening is very slowly the material are moving down slope very, very slowly. The movement is absolutely not visible to our eyes. But what we see is the fencing is tilted. The fencing is supposed to be 90°. No fence will be like this. The tree is curving because the soil is pushing it down, or a pole which is supposed to be straight is leading down slope. Why it is happening is because a rock, let us say a small particle, during the daytime it will expand. So, when it expands, it will expand vertically, and after the sunset, when the temperature becomes cool, it will contract and it will fall down. But while it is, I think I have to change what I said. When it is expanding, it does not expand vertically, it expands to the direction of the slope. But when it becomes cold, gravity will pull it to 90°. So, each time a particle is expanded and falling in two different directions. But this will take how many more years you cannot imagine. Even if the slope is very gentle, each of the particle which is sitting there is under this process of soil creep. So, in due course of time, a sediment which was occupying here will come here, but after hundreds of years, and we did not even see how it is moving. We can see it only from the evidence that rock layers are bending, fencing are bending, etc. And they are very common. You have to open your eyes and see next time that such kind of pictures are there everywhere. So, soil creep is a very slow movement, but I must tell you one thing, however slow it is, this is the most ubiquitous, that means it happens everywhere. You do not need very steep slope for soil creep to occur, even if it is 1 degree or 2 degree or 3 degree, this process is going to occur. So, do not confuse between these two things, rock fall or landslide. They are very quick, but they occur on the steeper slope, whereas creep, they occur anywhere, but on the lesser slope, but they are very, very ubiquitous. And another one is solifluction. It is a type of mass wasting in where waterlogged earth material moves slowly down slope over impermeable material. It occurs in periglacial environment where melting during the warm season leads to water saturation in the thawed surface. So, in the permafrost area or periglacial area, permafrost is different, permanently frozen. Periglacial means sometime melt period is there. So, during the melting period, the snow or ice which were accumulated on the surface is melted and it is mixed with the top surface, and it becomes saturated and slowly start flowing down. Very, very slow movement. Once again, their movement is not visible to our eyes, but signatures are there everywhere. They are called as solifluction lobes. So, wave like this kind of deposits we will find everywhere. Subsidence. Subsidence is very common. Whenever a support goes from below, it just goes down. So, let us say we have mining, areas where mining is very common. You see it is coming down all the time. Yeah. So, subsidence is the rock is sitting down, and sometimes it can be very, very large scale, or sometimes it could be very small scale, and Mahabaleshwar and Panchgani we see this kind of some blocks. So, subsidence or slumping, they are common in such areas where the support has gone from below. We find them in the coastal areas where sea water is removing only the bottom part, and one day it becomes unstable, and they are invariably there in the areas where underground mining is operated, because the support goes. So, when situation like that comes, the land is just sitting, and also many times we see the railway line going a step down, or the edge of the cliff is just removing from the face and it is slumping down. So, slump and subsidence, they are also two type of mass movement, and they are also not very fast, they operate very slowly. So, slump from the upper part of a hillside, and they occur most commonly in the humid areas. So, in the humid climate, the slump is very common. So, now we have seen that mass movement occurs wherever the slope is there. There are fast movement, there are slow movement, but there are some common factors. We call it as factors affecting slope stability. So, slope stability is safety factor that we already spoke about, S and F, whether the resistant force is more or the driving force is more, that decides. So, type of material is the first and the most important part. So, now let us now look at the hypothetical situation. We have a rock, massive rock, there is no joint, there is no weathering, it is just a rock. So, now you tell me which mass movement is going to pull a huge rock down slope? It is not possible. It has to be broken or it has to be softened. The joints should be widened. So, it means some part of weathering should have happened on that. So, what type of material? And not only that, whether mass movement will be occurring or not also will depend on how the structure of the rock is. If we have weak and strong layer, weathered and unweathered layer, if we have slip planes, they will all promote. So, type of the material or lithology is one and the most important factor of slope stability. So, in short we can say the more the rocks are weathered, they are less stable, the less they are stable, weathered, they are more stable. Slope, of course, the steeper the slope, more will be the pulling down. This is very straightforward. So, if I am looking at 90 degree or 85 degree or 70 degree, rock fall or mass movement will be more here, whereas if I compare it with a slope of say 10 degree or 5 degree, maybe soil creep, but slope failure will be very unlikely. So, slope plays a very important role. Climate, of course, whether rainfall is more, that is where always the mass movement becomes more. That is why mass movement is actually more predominant when we say rock fall or landslide, this kind of very killer kind of mass movement, destructive mass movement, they are associated with very humid climate. And also we know rainfall, a heavy rainfall is the kicking or triggering factor. Vegetation stops. So, when the vegetation is more, it will bind the soil, the roots will bind the soil, and by and large, not necessarily always. Wherever the slope becomes, vegetation becomes more, it is a lot less. That is why when vegetation is cleared by burning or by wood cutting, mass movement becomes more. Water, I do not need to say, I already told you. What water does is, it goes into the pores and it expands. So, and it is pushing, making it very weak. That is why in the winter, in the month of December and January, you do not hear anything about rockfall or landslide, but only during the monsoon. That is because water is one of the most important triggering factors, and time. in geomorphology, everything that we study, everything, time is the most important factor. With more time, the processes will work, they become more mature. So, if I am looking at a rock which is freshly exposed, all these agents or all these factors, they have not worked upon it for a long time. So, they are more stable. And I am looking at another area where it has been sitting here for thousands of years, it is already weak, because agents of denudation and weathering, everything has worked on it. So, time is a very, very important factor. In one sentence, the more the time or older the landscape is, more susceptible it is. And the role of earth material, I have already told it to you. So, when they are formed on the weak shales or they have got the bedding plane, it will promote more. And when the slope becomes steeper or land is higher, there will be more of mass movement. And then climate, I do not need to say, all work, freeze and thaw, drying and wetting, intensity of rainfall, all this will play a very, very important role in the triggering of the mass movement. The role of vegetation can be twofold, either it binds or sometimes it even breaks, but whatever it is, by and large, where the vegetation is more, they are mostly protected, but I already told you it is not always. And water can affect slope stability, shallow soil slips can develop during the rainstorm when slope becomes saturated. Rain or irrigation water seeping down to layers of weak clays which expand and lose strength and sliding begins. Water contributes to sometimes resisting force. When sediment pores are partial, that means, let us take an example that I take a glass where I fill it with sand and I make it upside down, it will all flow out, sand will not stand, but I will put some water into it, some 5-6 spoons of water and just make it wet. I will put it upside down and it will stand. So, cohesion. So, water first bind them together, but if you increase the amount of water, then it will start flowing. So, water, if it is to a certain amount, it makes it cohesive, but it will start flowing when the water becomes more, and that is why water is always associated with the mass movement. So, bank slumping, sliding are very common. So, water is doing all kind of things, and the role of time. The more the time is, the more the driving force will become. And finally, we need to understand the difference between factors affecting and triggering factors. Factor affecting means all the factors that we have discussed now, making the rock already weak, it is just waiting for an event to trigger and kick it down. It will be a heavy rain, or it could be earthquake, or it could be dynamite, because we know that when a dynamite blasted, we see the rocks are falling. So, what is happening is it triggering. The rock was already loose. So, when the rainfall occurs, it is triggering, already it was susceptible. So, a triggering event is either earthquake or intense rainfall, or as we have seen that water is removing the down portion of the bank, and one day it becomes so heavy and it goes down. These and deforestation, devegetation, we cut and clear the vegetation and it triggers a mass movement. So, it could be due to external as well as internal factor. Water will carry sediments to the stream, creating a series of caverns that seriously weaken a hill. Excavation, that also. And the best example I will give is Mumbai-Pune highway. Mumbai-Pune highway, the expressway, before it was built, there was no such mass movement. Now every year we see, because we have loosened the whole fabric. The natural support has got removed. So role of excavation and mining, they are all triggering factor. So let us summarize the whole thing. Mass movement or mass wasting. Material moves downslope due to pull of gravity. First, it can happen almost everywhere. Why I say almost? Because it is not very effective at the flat area, but we do not have absolutely 180-degree flat area is very rare. So, it happens almost everywhere. Triggering event and factor affecting are different. Triggering event are heavy rainfall or earthquakes or a dynamite or something that kicks. Movement can be either very rapid or it can be very, very slow. The rate of mass movement can be increased by various erosive agents, especially water. It happens at and mass movement happens below the ocean also, because ocean surface is full of mountain and it is happening all the time. It is not necessarily, and in India, the Himalayan areas and Assam, Manipur, these are the areas where hazard is very high, because they are very deeply weathered in Himalayan topography, and we see the whole of India actually, except for Western Ghats and the Himalayan track, mass movement threat is not that much. So, some of the pictures to make it interesting, this is the solifluction lobe, and the picture I have collected over the years, and I think with this I will stop it. In a nutshell, a summary of this chapter, mass movement or mass wasting. Gravity induced movement of the material from upslope to downslope. There are different types. If we look at the speed at which the materials are getting transferred downslope, there are 4 types. That is flow, fall, subsidence as well as sliding. There are, if we look at the speed, there are 2 types, slow and rapid. They occur everywhere almost. In the flat areas, they do not occur, but we actually do not have very flat 100% flat area. So, it is occurring somehow or other. There are different factors which affect mass movement. We just need to understand the ratio of driving force and resistance force. Water plays an important role, and triggering event is different than factors affecting. And the material which is brought down by mass movement is deposited downslope as scree. In due course of time, river will take it away from here and it will get deposited elsewhere. In the next lecture, we will see a very interesting chapter, that is karst topography. Karst, that is, karst is one such geomorphic process which is unlike any other processes that we discussed earlier. When the limestone is there, the process is just solution and it gives rise to dramatic landscape. So, next we will be doing karst or limestone process and the landforms and how they are distributed over the globe.